All right. Yeah, thanks everyone. As you can see, my PowerPoint's a bit more dark and dingy than everyone else's to reflect the ethos of bounty hunting. Um, Quick intro, me, yeah, studied at Imperial, graduated in 2018, started my career at Dyson, moved to kind of startup space in Graphcore. Um, that's sort of like my passion in kind of startups, and in the last like 9 months or so really got interested in the web3 space, and particularly bounty hunting and auditing. So my focus has been on Solidity and EVM based chains. So there's a lot of work going on Rust at the moment, and Solana, some interesting hacks happening there, but not an expert at that, so I won't be able to answer any questions. Yeah, I mean, this PowerPoint is going to be quite high level compared to the last two talks, so hopefully it's not too boring. But yeah, if you're interested in bounty hunting and think you might have an interest, what is it actually like? Well, it's a lot of reading code. To be honest, you're just plowing through lots and lots of lines of code and trying to build a picture of what the protocol is doing. How does it interact with other protocols? Where are the edge cases potentially? And you're starting to build a picture in your head by reading this code. So you need to enjoy reading code. And yeah, when I started, I remember first few times, I think I found a bug, and then I'm like, oh wow, you could steal like $10 million from this project. It'd be so cool. And then you start writing a proof of concept and realize it doesn't actually work. So there's a lot of that at the start, but part of that's learning how to write good proof of concepts. And then duplicates, the same with Web2. So you might find a bug in a project, you report it to the team, and they get back to you and they say, oh, someone else has already reported this and you've got to deal with it. They get paid, you don't. That's part of life, and you've got to move on and find the next bug. And yeah, projects can be pretty terrible. Some of them advertise that they have a really great bug bounty program. They'll pay you X amount for finding this type of bug. But that's effectively like a marketing exercise for them. And they always try and push you down. So my advice and what I found from experience is that these bigger projects are much more willing to pay out these big bug bounties. You must have seen in the news of people getting paid, $5 million, $10 million for finding bugs in these really big projects. And then, yeah, you have to be comfortable not finding stuff for long periods of time. So when I started, I think it took me 2 or 3 months before I found my first bug. And you really have to enjoy, what you're doing. Otherwise, you'll get burnt out pretty quick. But when you do find it, super rewarding. And yeah, if you like solving puzzles, I think bounty hunting is a good way to do it. So how to get started? I would, speaking from a Solidity point of view, the obvious point is learn Solidity. If you've learned any other programming language, it'll be super easy, very simple language. Won't take you more than a week or two. Then knowing Solidity, move to capture the flags. So there are ones called Capture the Ether, Damn Vulnerable DeFi. There's the Paradigm CTFs, kind of in order of difficulty. And capture the flags are, if you don't know where they are already, they're code that has a bug in, but you don't know what the bug is. So when you're looking at this code that there's a bug somewhere, and you have to figure out what that bug is. And that makes it approachable because you're not going to waste your time looking for a bug that may or may not exist. That obviously changes when you look at real projects, because you could spend hours and hours and hours planning through code but never find a bug because there isn't one, but there also might be. So that's the difficult decision you have to make, is how long do I spend on a project before I give up because I haven't found anything. And yeah, you have to be familiar with common standards. So ERC20, spoken about a lot today. You really need to understand how that works, how ERC721 works, 1155. Yeah, basically, what are the common building blocks that all these projects use and how do they work? Because if you don't understand that, how you can understand what the potential exploits are. And then my advice would be just get started, pick a bug bounty. Definitely pick a project that looks interesting to you. Don't just pick the biggest number and chase after it, because you'll get burnt out pretty quick and just bored, to be honest. And it's obvious, but I'll say it anyway, don't run any tests on mainnet or testnet. Even if you're not exploiting the project itself, let's say you're just doing some testing around the side to see if the kind of setup for it works. There are black hats that will monitor the mempool, so and past transactions, so you don't want to give them clues as to where a hack is, so always use a local fork. Then, yeah, how do you get better? Read audit reports from top firms. You find lots of new interesting avenues for hacks. Same goes on Medium. The Immunefi have some good resources about all the past hacks that have happened, and they'll kind of walk through how they'll kind of structure the project, how the project works, and then they'll build up to what the bug was, how did the attacker exploit it, and yeah, that's how you get better. You learn all these new techniques. Practice writing proof of concepts. I talked about that earlier. You need a proof of concept to get a bug bounty payout. So you need to be able to write good proof of concepts. You can use Brownie, Hard Hat, Foundry. Those are kind of the main ones at the moment that I use. I particularly use Hard Hat. That's kind of my favorite. Started using Foundry as well, which is sort of you write your test in Solidity instead of in JavaScript. Was really good the last time I used it, so I might start using Foundry more, but do your own research and kind of pick whatever you prefer. And then also, yeah, try and write the same exploit yourself if you read about it in the news. Obviously, again, on a fork, but that's a good way of having read about an exploit. Can you actually program it yourself and write your own kind of exploit for it? So that's kind of high level bug bounty. I'll do a quick walkthrough of a bug that I've found. I'll kind of rush through it because it's late and probably not that interesting. But yeah, just as an overview, this was in a project called Lossless, and their main product is a extension to the ERC20 token, so the LERC20, and it adds this extra functionality on top of the ERC20 where the community can report transactions, so movement to the token, and it will freeze the token so the attacker who did the exploit can't transfer their token anymore. Then the community votes on whether that exploit was valid or not, and they stake tokens to do so. The person who reported it, if it's valid, then the tokens get returned to the project. If not, then the reporter's stake gets slashed. So there's kind of that incentive mechanism. So they had this extension called a settlement time, which if emergency mode was activated, you would only be able to transfer tokens that were settled. So let's say they had a settlement time of 30 minutes. If a token transfer happened less than 30 minutes ago, you couldn't transfer it further. So this would apply across all the addresses using said token, not just the attacker. So this, like I said, is an optional extension to the protocol. Can you read that sort of? So this is a snippet of where the bug is found. And this, although it's private, it was called every time when calculating the user's settled balance. So that's when they're trying to transfer in the pre-transfer hook. It would check how much of their balance was settled. So let me point at it. So the bug is in this line here. So line 384. And what happens is this second variable, the second return value, so the lower +1, updates q.first. So updates lower, and then lower is used, or so q.first is used to pick out lowest checkpoint. And lowest checkpoint is the last incoming transfer. I think I got that the right way around. So what we can do is, in this bug, you can force that same logic to run multiple times. So if you transfer a token outgoing multiple times in a row, you will hit that same loop. So you'll get to the same point in the loop. You'll keep incrementing lower plus one, and lower plus one will then mean that Q dot first is bigger than Q dot last. And Q dot last should obviously be bigger because it's kind of like an incrementing array. So you don't want one to go past the other. And the free balance calculation is the total balance of the user minus the last cumulative amount, sorry, last checkpoint amount, plus the cumulative amount. So yeah, so we can effectively, we can get lower plus one to keep, sorry, we can get Q dot first to keep getting incremented because it's returning lower plus one. And as a result, lowest checkpoint points to an empty storage slot. So that means the lowest checkpoint or cumulative amount is 0 when it shouldn't be. Again, I kind of brushed through that. So yeah, what this means is that if the number of cumulative outgoing transactions is greater than the number of cumulative incoming transactions, then you have that condition where you're pointed to an empty storage slot. And the result of this is that the user would only be able to transfer balance, no more than balance minus last incoming transfer. So there's an example there where you have 10 tokens and then you transfer one token 10 times. So that's 10 cumulative outgoing transactions. So that increments the lowest checkpoint by 10. So now it points to an empty storage slot. You now get an incoming token transfer of whatever that is. But now balance minus last incoming transfer is 0, which means that a user can't transfer any of their tokens, even if they're settled. So the impact of that is that an attacker, so any random person, could file reports on any address in this project. And if the project was using this extension, it would mean that anyone's account, anyone's address that satisfied those conditions would not be able to transfer any of their tokens in that case, but in other cases, a subset of their tokens. So affects token liquidity and thus impacts the token price. So that's kind of the impact of that bug. Yeah, so kind of to wrap up, if you're interested in bug bounty hunting, it takes a lot of patience and you have to enjoy it. I would say don't jump into it for the money because most people don't get the big bounties. I haven't got one yet, otherwise I'll be living on a beach somewhere. And yeah, you can go months without finding anything, it'd be quite disheartening. And you've got to be ready to put up with people arguing lower severities. It's a bit annoying. So like I said earlier, aim for kind of these bigger projects. And challenge yourself, aim for the complex projects. The more complex the project, the more chance you have of finding a bug. If it's like a 300-line project, then chances are enough people looked at it that there's nothing interesting there. So there's no point you looking at it as well. And yeah, definitely join the Immunefi Discord. It's a lot better than this PowerPoint. Tons and tons and tons of great resources there. Yeah, really recommend it if you're interested in kind of bounty hunting and auditing in general. And that's it. Yeah, if you want to get in touch, feel free. Yeah, any questions? Go ahead. Yeah.
Yeah, so are there any other bug bounty platforms that you would consider, or is everyone just verging to Immunefi?
There's I think it's called HackerOne, also exists. I think that's more Web2 based, but with Web3 bugs on there. I think Immunefi are really pioneering the kind of standard of percentage payouts. So for these big bug bounties, it's not they're not forcing projects to do this, but their suggestion is for the projects to have a 10% bounty amount for whatever the exploit value was. So if you could steal 100 million, the bounty should be 10 million. they're kind of pioneering that approach to really incentivize white hats to be white hats and not be black hats. But yeah, I wouldn't use another platform for bug bounty hunting at the moment. Yeah.
Do you use any particular project structure for testing these contracts? For example, I saw some Clickbank repo. They use like Solidity contracts to test other Solidity contracts, or perhaps you use web3.js or something like that. You have a common structure of best practice to go through these tests quickly.
Yeah, I personally use Hard Hat, and the way I like testing it is I'll set up a really bare bones. I have a really bare bones structure for my Hard Hat test, so it's just one describe, and I have a before test hook or whatever it's called, where you do all your pre-test setup, and in that I get the on-chain address of said contract and just copy it into a variable, rather than cloning the whole project and deploying that on a local network. So I'll fork mainnet and then test with the address kind of coded in. The downside of that is that every time I want to interact with a protocol, I have to specify the interfaces myself, because there's no way for the compiler to infer what the interfaces are without me telling it. So that's the downside. But I prefer the kind of really bare bones test framework.
The only way, like either you import all the contracts and compile them yourself, or you purchase it.
Yeah, and I don't like, because every project does their setup slightly differently in their deployment. Sometimes that's particular deployment pipelines. You don't have to run the deployment pipeline. And I prefer just taking what's on chain, forget about how they deploy it, just interact with what's on the chain and kind of emulate that as much as possible. But like I said, Foundry looks really good, and I want to learn how to use it more, because I think it might be able to speed up my life a bit.
You test upgradable contracts as well?
Yeah, so for the upgradable contracts, it's effectively the same idea. You just you put in the address of the proxy, because that's where all the storage sits, and because I'm specifying the interface myself, I can just read that from the implementation contract manually and paste that into my my code. Yeah.
Might be philosophical, but how do you know when to move on?
That's a good question. It's a really good question. The advice, I can't remember who wrote it, but it's a well-respected white hat, and his advice was, when you can build a project from scratch yourself, then it's time to move on. So it doesn't mean remember everything. It doesn't mean copy it word for word. It just means you understand how all the bits will interact, and where all the pitfalls might be, and I can now copy it and build it from scratch. When that is sometimes a bit hard to figure out. To be honest, if you're getting really frustrated and bored of a project, then it's probably time to move on.
Have you ever tried the opposite strategy, instead of choosing a particular project and focusing on it, choosing a particular bug and trying to find as many contracts that might have that bug?
I haven't tried that, so an example of that was the UUPS kind of bug, where people could call self-destruct on the implementation. Because I think originally it was found in OpenZeppelin, and there were some security researchers who wrote their kind of a custom script to pass through all the contracts on mainnet to find any that had a similar pattern. So not necessarily that used the OpenZeppelin implementation, but they they kind of standardized it with what the bytecode would look like for something similar. So you can do that. I haven't done it. I kind of like this bug that I talked about today. I kind of enjoy these logic-based kind of bugs. So I like really understanding the project and trying to pick holes in the logic of the project, which you can't really generalize. And they're kind of the obvious ones that, you know, people have spent a lot of time protecting against, the re-entrancy ones. So people wrote their own scripts to kind of pass through and see which projects were re-entrance vulnerable. But to be honest, I think now there's very little left in that area. I've not found a single re-entrancy bug that's could do any harm. And I don't think they're popping up as much anymore. They're kind of found at the audit stage. But it's a valid approach, but I just don't do it. Yeah.
General advice about how to run the proof of concept.
General advice. Make sure what you're testing is actually testing what it's supposed to. I mean, in a previous project, I tried to prove something and I thought I proved it, but I wasn't, right? And I mean, that's quite a high level thing. So that's the obvious thing to say, is make sure what you're testing is actually what it's supposed to be testing. But otherwise, I'd say find a framework that you enjoy using, and keep your proof of concept as minimal as possible. And I think you should. The projects looking at these bug reports don't want to trawl through like hundreds of lines of code. So if you can demonstrate something in 20 that you could do in 100, definitely do it in 20. But be expressive with comments as well, because like in a previous bug that I reported, I had to manually set storage slots without calling it like a specific function. So I was just setting storage at arbitrary locations. So obviously without comments, that would mean nothing. So yeah, just be super expressive.
Thank you.
Cool, thank you.
Yes, I just said we can chat now.